All right, so in this last video on exponential functions, we want to focus basically on graphing exponential functions and different transformations of exponential functions. So we're going to do some transformations. We'll do some like reflections, and we'll do some shifts. So do some exercises here. So the instructions are to graph each function. So every function we have is going to be either a standard exponential function or maybe some kind of transformation of an exponential function. So I'm going to start off with number 1. Write it as y equals 2 times 3 to the x. So basically when you're graphing these, you need a y-intercept. First of all. So to find the y-intercept, you basically set x equal to 0, right? It's going to give you y equals 2 times 3 to this. We're plugging in 0 for x. So we're going to have 2 times, well, what's 3 to the 0 power? Anything to the 0 power is 1, so we get 2 times 1, so y equals 2. That's your y-intercept. It's also called the c, right? We could have saw that right here. That's the c. Okay. And once you have the y-intercept, then you have to find an additional point. So I'll plug in 1 for x. At x equals 1, what is y? So I'm going to have y equals 2 times 3 to the 1 power. That's basically what, 2 times 3? Y is 6. And then I want my horizontal asymptote, which we know a standard horizontal asymptote for a standard exponential, which this is, we haven't done any shifts or anything, is going to be at y equals 0. So to graph this out, I'm going to start off with a y-axis, I guess, and an x-axis. Okay. -2, -1, 0, 1, and 2 along the x. Along the y, we'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. So my y-intercept is at y equals 2, so right here in blue, and I have an additional point at 1, 2. 1, 6, my bad, right here. So your graph is going to connect those points, and to the right, it's going to increase. The y is going to go off to infinity, and as you go to the left, it's going to go towards this horizontal asymptote, which is going to be at y equals 0. Let me put in my horizontal asymptote at y equals 0 right there. Make a green dotted line. So let me actually label my points. I got 0, 2, and here I have 1, 6. That's good enough. Okay, so this is a standard exponential function. You have y equals c times a to the x, that form. Sometimes you get a shift of them, though. It'll be a little different, let's see. Or a reflection. Let's say I have y equals -3, parentheses 1/2 to the x. Okay, so this is not a standard exponential because if you look out front, this number out front, that c is not a positive number. It's a negative number. So remember when you have a negative, focus on that negative out in front of the house. That's going to reflect everything about the x-axis. So it's basically everything's going to be flipped upside down. You have to be aware of that. Let's start off with first finding the y-intercept. How do you find a y-intercept? Well, let's set our x equal to 0 here. So let's set x equal to 0. Y is going to be, let's see, -3 times 1/2 to the 0 power. Now you have to do your order of operations correctly. You want to do the exponentiation by 0 first before you do multiplication by -3. So we're going to have -3 times. What's 1/2 to the 0 power. Well, 1/2 to the 0 power, anything to the 0 power is 1. So we have -3 times 1, so y is going to be -3. It's our y-intercept. Okay. The next thing we're going to do, we're going to find an additional point. If I can spell additional, that'd be great. So I'm going to plug in 1 for x and figure out what y is. That x equals 1. Y is going to be, let's see, -3 times 1/2 to the 1 power. So remember, order of operations says exponentiation comes before multiplication, so I'm going to leave -3 multiplied alone. I'm going to do 1/2 to the 1 power. What's 1/2 to the 1? It's 1/2. So I have -3 times 1/2. That's the same thing as -3 over 1. You take the top times the top. -3 times 1 is -3. And on bottom, the bottom times the bottom. 1 times 2 is 2. So -3 halves. So y would be -3 halves, or -1.5, you could say. Now, have we done any shifting up or shifting down? If we don't have a shift up or a shift down, that would be like if I added 1 outside of the house, that'd be a shift up. Or a -1 here outside of the house, that'd be a shift down. If I don't have that, then I'm not going to be shifting my horizontal asymptote up or down. So we're going to keep our horizontal asymptote where it is at y equals 0. There's no change in that. So let's plot everything out. Actually, now that I think about it, it's going to be going upside down, right? Because we have this reflection. Because we have a negative out in front, we're going to have an upside down, or it's going to be a reflection here. Okay, so that's better. So we're going to take our points and plot this out. These are negatives here. So I'm starting with a y-intercept of -3, so that would be right here. And then I have a point here, which is 1, -1.5. So where would that be? That would be, so 1 on the x, -1.5 on the y would be about here. And we have a horizontal asymptote, y equals 0. So if I connect these, and if I go to the right, this should approach the horizontal asymptote. Then on the left, if you go to the left, this is going to go off to -infinity. That's the way exponential type function works. So I'm going to write these points in. This is 1, 1.5. That's my additional point. And then my y-intercept is 0, -3. All right? That's basically a reflected exponential function. It's upside down. Let's do a 3. Here we got y equals -5 to the x, and then -2. So if you look at this, this is not, don't mistake this for -5 in parentheses. That negative is not in parentheses with the 5. This is the same thing as -1 times 5 to the x -2. It's -1 times 5 to the x -2. That's the way you would read that. So it's going to be an exponential function, and since it has this minus out front, it's going to be reflected about the y-axis. I'm sorry, the x-axis. It's going to be reflected upside down about the x-axis. And this -2 outside of the house is going to shift everything down too. Okay, so first we're going to find our y-intercept. How do you find a y-intercept? Well, you said x equal to 0, right? I get y equals -5 to the 0 power -2. Let's see, what's 5 to the 0 power? 5 to the 0 power is 1, so we get -5 1 minus 2. What's negative 1 minus 2? It's negative 3. So here we have a y-intercept of negative 3. Okay? And we want to find an additional point. To do that, I'm going to set x equal to 1 and figure out what y is. At x equals 1, y is, so we'll have negative 5 to the 1 power minus 2. So you're going to have, first of all, negative, then do 5 to the 1. 5 to the 1 is 5, so we got negative 5 minus 2. So negative 5 minus 2 is negative 7. So we have a point of 1 comma negative 2. And finally, we want to do our horizontal asymptote. Well, normally you have a horizontal asymptote at y equals 0. But because we have this minus 2 here outside of the house on the end, that's going to shift everything down 2. So the new horizontal asymptote is going to be at y equals negative 2. So we went from y equals 0 and we subtracted 2 to get y equals negative 2. Okay? So if I wanted to graph this out, take my ruler, make an x-axis. And I know this one's reflected about the x-axis because that negative out in front. Okay, so the y-intercept is at 0, negative 3, right here. The y-intercept is at 0, negative 3. The additional point is 1 comma negative 2. That would be right here. And we have a horizontal asymptote at, oh, that's a negative 7. I say that? Negative 7, my bad. So when I do here, I go back here and I do negative 5. Come on. When I do negative 5 minus 2, that should be negative 7. So that should have been a negative 7. So negative 7, 1 negative 7. Let's find negative 7. Negative 4, negative 5, negative 6, negative 7. So 1 negative 7 should have been that additional point right there. So actually we're going to be connecting these, and as we move to the right, this thing is going off to negative infinity. As we move to the left, this should be approaching our horizontal asymptote. Where's our horizontal asymptote? Right here, right at negative 2. This is going to go, it's going to approach that. It was very sharp change. All right, so it's reflected about the x-axis and it shifted down 2 basically. Now let me write down these key points. We had a key point at what? 0, negative 3, that was our y-intercept. And the other key point was 1, negative 7. Okay, what else do we want to do? Number 4. Do I have a problem here for number 4? Yeah. We got y equals 3 minus x plus 2. So this is some sort of exponential that's going to be shifted and reflected about a y-axis. So, I mean, if you wanted to think about this, you could rewrite this as y equals 3. And then in parentheses, you could think about this as a minus parentheses x minus 2. And you could say, okay, this is basically an exponential function. You could say that this negative out front reflects it about the y-axis, and then this minus 2 inside of the house is going to shift it right to afterwards. But you don't have to go through those transformations here. It's a much easier way to do it, and the first thing to do would just be to find the y-intercept, like we've been doing. So to find the y-intercept, you set the x equal to 0, right? So you get y equals 3 minus 0 plus 2 up there. If I do that, I'm going to do, what's negative 0? What's 0? So 0 plus 2 is 2, so I get 3 squared. So y is going to be 3 squared, which is 9. It's my y-intercept. Then I find an additional point. If I can spell additional, that'd be great. I'll plug in 1 for x. See what happens at x equals 1. What is y? I have 3 raised to the negative 1 plus 2. In other words, 3 to the, what's negative 1 plus 2? It's 1. So y equals 3 to 1, 3. So when x is 1, y is 3. That's your additional point. And what kind of asymptote are we going to have? A horizontal asymptote. Now, normally you have a horizontal asymptote at y equals 0. Now, if you were to have a vertical shift up or down, that would shift your horizontal asymptote up or down. Now, do we have a horizontal shift here? No, we don't. You only have a horizontal shift if you have like plus a number outside of the house or minus a number outside of the house like that, but we don't have that. So we're going to actually have a shift left or right, but it's not going to be affecting the horizontal asymptote. So horizontal asymptote stays at y equals 0. That does not change. If I wanted to graph this, get the color right. That is the first time I'm actually hearing the cicadas. Cicadas on June the 27th. Okay, so we have a y-intercept at 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I have an additional point at 1, 3. 1, 3. Be right here. So as you go from left to right, these are going to connect. And they're going to approach your horizontal asymptote, which is at y equals 0. Let me write these points. And this is 1, 3, and this one is 0, 9. Now, as you go to the left, it has to go off to infinity. Okay, that's number 4. Let's do a number 5. So I have y equals 1/4 x plus 1, and then outside of the house plus 3. So basically what's happening here is we have a 1/4 to the x, so that's some sort of exponential function. This plus 1 is going to move everything left 1, and this plus 3 outside of the house is going to move everything up 3. So we're going to have to do a shift up 3, so it's going to change our horizontal asymptote up to y equals 3. Normally it's at y equals 0, it's going to go up to y equals 3, so we'll have to keep that in mind. Okay, let's just get started. Let's begin by finding the y-intercept. So how do we find that y-intercept? Well, we set x equal to 0. So that means y equals 1/4, 0 plus 1, and then outside of the house plus 3. Now if you do 0 plus 1 up there as an exponent, that's 1, so you get 1/4 to the 1 power, and then plus 3. So in other words, 1/4 is the same thing as 0.25, right? Plus 3, so that's going to give you y equals 3.25. So you have a y-intercept of 3.25. Now how about an additional point? Make that red, I guess. Well, we'll plug in 1 for x and see what happens. What is y when you plug in 1 for x? So I'm going to have 1/4. I'm going to plug in 1 for x, and then we have another plus 1 up top, and then we have a plus 3 outside of the house. So 1/4 plus 1/4 raised to the 1 plus 1 is 2 power, so I got 1/4 squared plus 3. What's 1/4 squared? Well, it's 1/16, right? 1/4 times 1/4 is 1/16. Or you could square the top. 1 squared is 1 and square the bottom, right? Let's think about this. 1/4 squared. It's 1 squared on top, 4 squared on bottom. So on top you have 1 squared is 1, on bottom 4 squared is 16. So 1/16. So y is 1/16. What's another name for 1/16 as a decimal? Let's write it as a decimal. Let me write this in my calculator. Type it in my calculator. 1 divided by 16. It's 0.0625. Very tiny. So when x equals 1, y is 0.0625. Okay, what about the horizontal asymptote here? Well, normally, an exponential function would have a standard one would have a horizontal asymptote at y equals 0, but here we have a +3 outside of the house, right here. That's going to shift everything up 3, so our horizontal asymptote, which is normally at y equals 0, is going to go up to y equals 3. So graphing this out, one, 2, 3, horizontal asymptote, that's going to go right here. Okay, y-intercept is at 3.25, so if this is 4 right here, 3.25 would be about here. And then the next point is 1, comma, oh, I forgot to add 3 here, didn't I? I should have added 3 here, 3 to 1/16. So if I add 3 to that, made an error, didn't I? That'll give me 3.0625. So actually, the additional point is 1, comma, 3.0625. So let's see, where is that? That would be like about here. It's really close to 3, but not quite there. So you can see the point at the y-intercept's a little bit higher than the one here at 1. So it's going to be descending here. So it's very gradually descending. So as you go to the left, it's going to be ascending to infinity. As you go to the right, it's going to be approaching this horizontal asymptote. Okay, well, do we have any more examples we want to give you? I don't know. I think that's enough. Yeah, that should do it. That should do it. So basically,